Did you hit start?
By accident, yeah.
I'm gonna close out and I'm gonna stop it. We're starting over, okay?
Okay. I'm closing out some screens. That's the problem. Here we go.
Are you there?
I'm here.
All right. Well, you hit start, so everybody's hearing us now. I don't have your meeting up though.
Nope.
Are you showing your screen yet?
You don't want to show. Choose screen application.
Hold on just a minute. I have to now again make you a presenter. Okay. All right. All right. Now, if you can go down to the go down to the bottom of your screen there, and that there's a little slide bar, and to the left of a little thing that looks like an old child's desk or whatever. Click on that button right there. That one. Nope. So are you using two screens?
How's that?
Can you hear me?
I can hear you now. How's that screen? See that one?
Well, I get to see all of your upcoming on the left, so I need you to try.
Once I hit the
When you hit that one, there you go.
there we go. How's
there
that?
we go. That's good. That's good. Dana and Mike, we're sorry that you're hearing us. We hit the start broadcast, and it is recording, and I'm sure you can hear us. So bear with us.
It's got a button that says stop recording.
You did?
No, there's one here, a red button to stop recording.
I got one that says only recording. I don't have a stop button one. Where do you? Hello, everyone. Welcome to today's webinar, Radiant Floor Heating Systems. I'm Jim Olson with the National Tile Contractors Association, and I want to welcome you and thank you for taking time out of your busy schedule to attend today's webinar sponsored by Mapei Corporation. Before I introduce today's speaker, I want to remind you that during the webinar you will be muted. Please use the questions area on your computer to type in any question, and we'll answer those at the end of this presentation. If the audio is poor on your computer, please call the number on the invite to this webinar and listen on your phone. All of our NTCA webinars are available to watch at any time on the NTCA YouTube channel shortly after the webinars are presented. This gives you easy access to watch and or share all current and past programs at your convenience. All right, here we go. Today's presenter, Barry Bailey, is a regional technical service representative with the Mapei Corporation. Before joining the technical services group at Mapei, he was the owner and operator of a flooring installation company specializing in porcelain, ceramic, marble, natural stone tile installations. Barry is a certified tile installer and has over 25 years experience as an installer and business owner in commercial and residential flooring installations. His past work experience in the flooring industry allows him to help customers with Mapei product recommendations and technical solutions. Barry graduated from the University of Georgia with a Bachelor of Science. He lives in North Carolina. Let's welcome Barry. And Barry, we look forward to a great presentation. Thank you.
Thank you, Jim. We appreciate the introduction. Guys, we're going to get started here today. Basically, it's heating mats and cable systems. We're going to kind of differentiate between the two and give you some benefits and maybe some ideas how to increase your business and getting some of these systems in some of your jobs. This is a AI continuing education credit presentation. So if you're interested in that, please make note of that and you can email us. We'll get you signed in for that. So we'll go through these little slides here, which is all about that, and we'll get started on our heating cable mat systems. Today, what our learning objectives are about 4 of them. Basically, to learn the different types of electric radiant heat flooring systems and their properties, understand the difference between radiant heat and using it as a primary and a secondary heat source, and look at the different system required installation processes over different substrate materials, and also look at the alternative solutions about using these mats instead of other heat sources. So why use electric radiant floor heating? Why? There's a lot of heating sources out there. Maybe one of the main is this, we all hear right there in the news of how much
Barry, excuse me. Everybody seems to be getting an echo from your speaker.
All right, let's see if we can do something different. How's that? You got echo there?
I'm okay. Let's go ahead and continue, and if I need to, I'll break in again. Sorry about that.
Okay, not a problem at all. Just let me know. Technology at its greatest here. So the benefits of using electric radiant floor heating is the heat's distributed evenly throughout the living space. You don't have cold spots per se. Using HVAC, of course, most all of your heat is going to be in the ceiling. You don't have that problem with a radiant floor. It radiates from the floor, heats from the floor, heats all your objects in the room and moves its way up, which makes it feel much more comfortable. It also improves air quality. The room feels warm, but also it's going to reduce mold, mildew, bacteria. It doesn't distribute allergens and like a dry forced air system. It feels, like I said, once again, it feels good when you just walk into the room and you don't have something blowing in your face. It's silent and invisible. You don't have that unit click on. Most people will have one, and I happen to have some of those. Is you hear that at midnight click on and kind of wake you up, so it doesn't disturb any sleep. It's nice and quiet. You don't have to worry about where furniture is placed against walls, where vents are located, or where baseboard heat is at. You don't have to worry about it getting too hot or worry about any children running up and grabbing the baseboard heat and perhaps burning their hands. No need for throw rugs. There we go. It's efficient. It doesn't waste energy by heating unoccupied spaces. Quick, it heats where you want it. So if you only want to heat, say, the kitchen and not worry about heating the dining area, you can just heat that area. Electric heat uses less energy, less output versus a gas oil system. And it adds luxury and value to the home. So when you sell it, you say, hey, I've had heated floors. It's actually going to up the cost of what you're going to recoup from your home. Requires little, and one of the main benefits I've seen, it involves little or to no maintenance. No worry about changing filters or that yearly system check from the HVAC guy. So let's look at the radiant heat versus forced air. You heat where you live instead of trapped air up in the ceiling. It's a warm and comfortable feeling of heat. Cold floor, like you walk into a bathroom in the morning and hit that marble floor, it's cold, makes you recoil. You turn on an electric heater and you hear a buzz on a base heat. Forced air circulates dust and allergens. One of the things, a lot of people have itchy, dry skin in the winter. A lot of times what that's caused is from the HVAC drying out the air. So it takes a lot of the moisture out of the air and it just gives it a dry feel. It doesn't happen with that radiant floor heat. It's maintenance free. Once again, doesn't strip humidity from the air. It doesn't circulate allergens. So there's quite a number of benefits of electric radiant floor heat over forced air systems. Over hydronic heat, we have two types of radiant heating systems in the market, one being electric, the other being hydronic. Of course, the difference in that is hydronic is quite a complex system. They have baffles and manifolds to make sure the waters run through whatever room it needs to go to. So it's not a simple install, it's a high cost installation versus electric system. It's not many parts and not really much to put in electric radiant heat floor system in. It minimizes electric, doesn't have a large buildup because your radiant floor heating doesn't have that buildup like hydronic heat. Normally it has to have a design professional build that 2-inch, 3-inch drop in the floor, which adds construction cost to it. So not only is it going to cost more to install the hydronic heat, it's also in the design cost and materials today. It's not cheap building materials today, as we all know that. The radiant heat electric, it heats up fairly quickly. In about 20 minutes, it starts to, you feel the heat, and it starts to heat about 84 degrees, which is where you start feeling the heat. On a hydronic system, the boiler has to heat up, the water has to circulate through, so it takes quite a while for that system to go start producing heat, and you need to keep it running pretty much constantly to keep the heat into the heat source. Unlike the electric radiant heat, it kind of monitors itself. If you have a heat zone, you can drop the heat down to 50 degrees at night when you're sleeping and pull it back up, so you can kind of monitor your heat energy that goes into the floor and save some money there. The main difference is you can't put it under carpet or solid wood, hardwood floors, which on hydronic heat you can in certain circumstances. So electric radiant heat versus electric baseboard heat. And this kind of gives you an example of how you get a monolithic feel of heat throughout the room. If you look at the picture there, you can see on a radiant floor heating, it heats the whole floor and it's consistent, versus a baseboard heat. It's warm over by the baseboard heat, but if you stand across the room 10, 15 feet away, it's cool. It's a much different feel to it. And you have to turn that up to reach the same BTUs. When we're measuring heat using BTUs, but an example is a heat source from radiant floor heating in the same space, it'll heat at 41 BTUs versus a baseboard heat, same area with 34. So you have a much more efficient heat source, and it heats it more consistent. It heats the entire room evenly, and it's invisible. It takes up no space like the baseboard heating. Normally, most manufacturers, their standard heat that's put into the floor is about 12 watts per square foot. That's up by standard. There's some manufacturers that can get it up to 15 or drop it down. It depends on what you want to do. You can take the chill off the tile, you can heat this place evenly, or you can use it as a whole house radiant heating if you get it up to 15 BTUs. But the radiant floor heating uses less energy, it's more efficient, and is easier to maintain than electric baseboard heat. So let's say you've heard a lot of people, it costs a lot to run electric radiant floor heating. It just runs too much. So here's a little example of what we're looking at if we do it. I'll calculate it out. Now that was a 2017 average, so you could probably double, but I don't know where energy is today, but it's still cheaper than running a gas oil furnace system. So if you have a let's say a 50 square foot bathroom, and you run it 5.5 hours, it's 18 cents to run that for the day. Pretty cheap. Let's go a little bit larger space. The kitchen, you run it 7.5 hours. It's 150 square feet. We're looking at 74 cents for the day. And if we add a living room in there, even a larger space at 200 square feet, we're looking at a little over $1 a day. So all that put together, 57.90. If we doubled it, let's say even with the energy cost today, just in case it double, it's $114, $115. But running a example of, say, the kitchen for 7.5 hours, most people are not going to do that. What you're going to do is you're going to put it on a thermostat that is programmable. It's going to warm up at 6 o'clock in the morning, stay warm to 9, 10 o'clock. Most people, if they leave to go to work, they're going to let that floor drop down to 50 or so degrees. And then when they come back in at 5 o'clock, they'll pull the heat back up. So your cost is going to be significantly less in the long run when you use these programmable systems. So you can see where it's much more efficient than the other systems. So it gives you a lot of options, or you can use that as a primary heat source, as we showed in the room, or you can use it to augment some areas. I personally had a vaulted ceiling in a master bedroom that we could never heat. If we heated it, we would fry everybody in the rest of the house, put a radiant floor heating system in. We turned the vents off, and it was the most comfortable room in the house. So there's some options that are available to the tile contractor to pass on to their customers, show them there's ways that can actually save them money and have a much more efficient heating source in their home. Now, installing these electrical systems, always check with your manufacturer on how they expect their systems to be installed. That's to maintain the warranty and safety and be within electrical code. So most of these, this is a generalization here on what's required for most manufacturers. Installation consideration on this is what type of floor are you installing? You're putting stone, tile, laminate, engineered hardwood, or luxury vinyl. And once again, caution you with a laminate, engineered wood, and luxury vinyl. Check with the manufacturer of those to make sure that you can install those over radiant floor heating. Many these days you can. Some you're limited to. So just check on those. Once again, check with the manufacturer of your wire manufacturer and of your floor manufacturer. And this is a two-trade install. You got your flooring installer and you got your licensed certified electrician. Always on all manufacturers, the final hookup to the power to the residence or whatever building you are, the electrician is to do the hookup. The flooring installer can lay the wiring in the floor, set the tile, do everything that's necessary, but the final hookup to the power must be done by a certified electrician. And that maintains your warranty and makes sure you're within code and everything is good to go. Most all the systems out today are going to be a 120 or 240 volt system. Just the standard amount of heat that's put into the floor, most of the manufacturers, is 12 watts, which what that is that guarantees that you can warm the tile surface. Let's say if you're doing stone, 3/4 inch stone, it'll warm that stone surface, be nice and warm, and you can keep it up at a little higher rate to warm the whole room, or you can have it just take the chill off in the morning. That's kind of up to the customer what they want to do. A lot of people want to know, is the 120 versus a 240 system. Does the 240 system heat the floor up any hotter or quicker? No, it does not. Basically, that just the 240 system just allows you to cover more square footage. So a good little mnemonic device to remember is most manufacturers, if not all, at 120 volt, that normally covers about 120 square feet of heated space. If you got to go to a larger space, the 240 system normally covers around average up to 240 square feet of heated space. So if you've got a large kitchen that's say 200 feet, you would want to go with a 240 system if that's possible, or you could go with two 120 systems, but you can never cross the two. You can't wire a 120 volt system and a 240 volt system to make up the difference. So I'll keep that in mind. And in some instances, when you have a multifamily housing, I call them the millennial beehive. My son lives in one where the retail space is below and they live in apartments above. Some of those are on a 208 volt system, and you need to make sure that you're on the same page as your electrician and make sure what system or what voltage your system's running, because that could cause a major problem if you try to run a 120 system and you got a 208. It will last about 2 seconds and be smoked. So just be cognizant of what you're doing. Most, like I said, most residentials are going to be 120, 240. When you get into a commercial multifamily system, just make sure what that voltage is coming into that living space. Once again, it's a 2-trade installation, so you got specifying Division 9 is going to be your finishes, which will be falling under your tile installation crews, and Division 23, which will be your HVAC and your electrical. Safety-wise, all of these have to have a dedicated circuit to them, and all the thermostats have a GFCI ground fault circuit interrupter built into them. So that's your safety there, in other words. But just make sure the electrician does the final hookup and you'll be good to go. Most of these, if not all the systems, are going to be UI and UL rated. Some of those many of them are UL rated for intermittent wet areas, so you can warm a shower floor or a shower bench. Just check with the manufacturer to make sure that's the case. Application. So that's mainly when you're looking at electrical radiant heating floors. Here's most of your areas that they concur at: kitchens, bathrooms, shower benches, and shower floors. That's primarily where you see them at. But additionally, you can do your bedroom, any living space, entryways, mudrooms, and utility rooms. Just think of the areas you can put it in. If you see the nice kitchen there, what you got to look at is those are some smaller mosaic floors. So many, not many, but a few manufacturers allow you to pour a floor level over the top of their membranes, which will allow you to put those smaller mosaics over the top of it, or use LVP, LVT over the top of those. Yeah, also, in your more of a commercial or spaces with large windows, you tend to have a lot of condensation in the wintertime when you run a standard HVAC system. These will allow you to run that electric radiant heat floor, and you will not have that condensation. You'll keep that area heated up, nice and warm, and basically, as long as you have modern installation practices, you'll have a much more readily heated space. I'm going to say it'll feel better, as we say. There's many systems out there. Here's 4 different types that are very popular. Basically, there's a custom pre-made mats. Company I'm with actually has 70 standard sizes. They're the thinnest system that you can put out there. They're very thin, low profile, and there's no manipulation of the wire. So they're pretty much set. A DIY can do these fairly easily. Well, I say that, we hope. Then you go to your next, which most people are familiar with, is the heating and coupling membrane, which you have on site. Put your wire in on site. It's a quick, easy way to install floor cable. They have varied wattage options, and you can use self-leveling over some of the manufacturers. Once again, check with your manufacturer on those. Your commercial load-rated grade load. Commercial grade load bearing. Then you have your old school way, which is your old flexible cable, which I started with many moons ago. Is you just use cable guides, put your cable out and pour floor level over the top of those. It's still a viable way to do it. And there's some mesh systems out. We'll go over each one of these, kind of let you look to see what's out there. Along with that, operating these, there's an array of controls to operate these. Thermostats are basically, there's an on and off type thermostat, just on and off for those people who have problems with technology. Some people just want to turn it on and off. Then you have your programmable one, which, like I said, you can do 7 days and have it come on and off at different times of the day. Saves you some energy that way. And the new Wi-Fi, and these connect up with Alexa, and you can tell Alexa to turn your floor on or off, Google Assist, and whichever Wi-Fi system you tend to go with, and you can look to see on the Wi-Fi what the temperature of your floor is, or you can turn your floor on as you leave work and have your floor warm when you get there. Some pretty neat little things that are out there now with this technology. So pre-built electric mats, this is kind of what they look like, the rolls there. You can see the nice tub and the large window there. If you were trying to heat that up with a regular standard HVAC system, all the heat would probably be in the ceiling. It'd be cool. It's nice to step out on this tile and be nice and warm. There's the mats, fairly simple to put in. These come in 120 and 240 in different sizes. Basically, you roll it out, check it out, the dry fit in your area. The system's a 1/4 inch thick. You got the wire already set for you, so there's no guesswork in it. Like I said, there's available in 120 and 240, and you got the 2 wattages. And you can, which is 12, or the 12 is going to be your standard heat, 41 BTUs. 15 is going to be your higher output. If you really want to not use any other heat in the room, that 15 watts will heat the whole area with no problem. There are also custom mats, and you can see this mat here on the left in the picture is made for a shower floor. Basically, you would just then set the mat, and then set your towel over the top of the mat. You're good to go. You have a heated shower floor. You can get a custom mat. There's ways to, there we go. The measure for custom mat. And once again, you want to see there's the thermostat where the T's at. That's where your power would come in. Your heat probe sensor would come out into the floor from that location. You would measure the perimeter of the room that you want heated. Be cognizant of the toe kicks, the flange of the toilet. We don't want any cabinets sitting over the top of it, any tubs or anything of that nature over the top. So be on the same page as the GC, the plumber, the electrician, the homeowner, who it is. All need to be on the same page, at least to go you have a pre-construction meeting and get everything ironed out and have that drawing approved by everyone, so you don't have anybody drilling a hole or coring a hole through any heated wire, because that can cause a huge problem, of course. So once again, this little overview of it. You thin set, roll the mat out, and thin set over the top, and install your tile. Only an 1/8 inch thick. So there's a lot of options for the tile contractor to give someone, especially on a remodel, if you're worried about elevation. There's no additional elevation whatsoever when installing a floor with this. So it gives you a lot of options. Then this is one probably most people are familiar with today. It's very popular. It's the uncoupled membrane. You can see the plywood floor, the thin set, the mat, the heated cable, thin set, then tile. You can see you can run that straight on into the shower and have the heated floor into the shower. This system here, you see it's a 3-3-3 situation. That would be a low output, and this manufacturer of 10 watts. So 2 things it does is uncoupling membrane separates the movement of the floor from the tile, isolates cracks, it can replace the backer board. Instead of putting the backer board down, replaces that. Like I said, in the shower, it can be totally waterproof. It allows for a varied installation of heating wires, so you can manipulate that a little bit and adjust it as needed. It's approved, every manufacturer see what mortars it's approved with. Most approved modified mortars these days. And wires in the thermostat just click right into those pucks. They just snap right in. Very easy to install. You can see close below, there's the pucks. These basically are what a mechanical bond. There's a dovetail in these pucks. That's how that holds it over that plastic membrane. Like I said, this one's set up here as a 2-2-2 system, unlike the 3 before. This is a high output system, and you can see how the wire just snaps in and rolls around. So you have to kind of lay this out and be somewhat familiar of what's going on with the wire in the area you want to do. Membranes come in rolls, they come in sheets. So that's kind of the choice of the installer and the manufacturer. All manufacturers pretty much have a cable description of what's going on. These, like I say, this one here is 10 watts per foot for low output, 12 for standard output, 15 for high output. Pretty much everything you need to know about the wire itself. And here's the assembly again. You got an exterior rated ATA plywood, a thin set. Then the mat goes down, the wire, thin set or leveler on this particular one, and then tile. So it's pretty straightforward on what you need to do and how it's done. Once again, you can put it in showers. You can pretty much anywhere. It's not made to go exterior, it's only interior and not vertical. So always you can do shower seats, but we don't want to go on the vertical or exterior. Here's the old school way to do it. This is we're just using the old cable with the wire guides, and you can see this kind of shows you how an installation would go. The T is where the thermostat, that's where your power would be in, be at 120 to 240. You'd have a heat probe that would come and sit in between the two wires, and that would monitor how hot the floor would get, where you want to keep it monitored at. Be cognizant of the toe kick of where this is at. Also, make sure you're on the same page as your local municipality. Some will require different distances from walls, be it 4 inches. I've seen as far as requiring 6 inches, but not many people walk 4 inches against the wall. So when you're calculating that out, you don't necessarily have to run that heat wire all the way beside into the water closet against the wall. That's if you want to, you can, but it's kind of useless area to heat. But wherever the wire is not, that's not where the floor will be heated. You'll feel a cool difference. And some manufacturers, on the place you're installing the wire, will put this as a halfway point to kind of give you an idea. If you've got almost, you come to the halfway point and you're barely into the room, then you've miscalculated quite a bit. So this kind of gives you an idea where you're at in your install. A little inside information, if you ever have to pull this wire back up and readjust it, pull it back on the spool, because if anybody fishes as a fisherman, the backlashes and the twist on that wire gets fairly significant, and it's a mess. So put it back on the spool, don't try to wind it up in your hand. So here's our old school way to do it. We apply the primer, we install the cable guide, lay out the cable, and pour self-leveler. And I know that's some manufacturers' magic invisible primer there on that plywood. I'm not sure who it is, but it looks like it's not there to me. But and there's your tile installed. So basically you put it in the same way as you would snap it into the mat. You just don't have all the benefits of that membrane and the waffle mat. It's an isolator and being waterproof and no vapor. Then you have, lastly, the mesh system. This is a little older system, but it's still a viable system. Still a thin rollout. This sticks to the substrate where you roll it out. And here's I'll give you a little example of what I'm talking about measuring a room. Let's say if we take pull up this, we've got a 9 by 10, a 90 square foot bathroom. Well, how much wire do we really need? Well, we don't need to cover under the cabinet, so we minus 10 feet. The toilet space area behind the toilet area, we don't need to heat that. The linen closet, we're not going to heat. In the shower, they don't want to heat the shower. So we have a total area of 51 square feet. So the difference between the 90 square feet of total area that we're going to install, or say tile, versus 51 square feet is quite significant. So when you're estimating or looking at this, it's not nearly as much heat wire that you need to do this space. So it can be quite efficient and quite not as expensive as a lot of people think. So 51 square feet is not a huge system, but it will warm that room and make it feel much more comfortable and save some money on the heating bill. But back to the mesh installation, you roll it out and clip it, it flips around, and you pour self-leveler over it, or you can tile directly over it, your choice, and install the tile. Very simple to do. With a little bit of experience, I guess it is. And a lot of manufacturers also, and we suggest connecting a electrical heat fault sensor. This connects to the wires, your two heated wires and your ground. So while you're doing the install, if there happens to be a nick or something in the wire, it will signal alarm and know that's the spot where there's most likely a problem. So we want to avoid that at all costs. And if there is a problem, or someone does put a nail, or Tommy the trim carpenter shoots a 3-inch trim nail in the floor and it kicks back into your wire, which I've seen happen, there's a way to repair these. Just check with your manufacturer see how they would like you to have that repaired. If they have someone that comes out and does it, or a licensed repair technician, so you can maintain the warranty for your system and for your customer. But there is ways to repair it. Once again, with the technology, the new thermostats, as you see here, this thermostat, they're showing that the floor is 84 degrees. It's 11:15 a.m. on a Monday, and it's 68 degrees outside. So it's not very cool outside, but we got an 84-degree floor inside. And all this, this is pretty much a LED screen. It's very easy to use, and basically most thermostats have a 1 to 3 year warranty. Check with your manufacturer on, you have to do the proper testing to get a 10, 15. Some manufacturers offer a lifetime warranty, but that requires you to take a class and get certified in doing that on a lifetime. See the 7-day programmable, I-5. So it's pretty much straightforward on this, but the main gist is to let you guys know that the radiant floor heating is not nearly as expensive as the impression. Over the years. It's really become quite competitive in pricing. It really adds to the comfort of a home, and it's very a great system for the tile contractor to put in his bag of tricks and arsenals to help them recruit or make more money. And once you have a heated floor, and I can attest to it, you'll never have another floor without one. It really sells itself. So if there's any questions, we'd be happy to take any of those. Jim, are you there?
It's great. I'm talking, but nobody can hear me. Can you hear me now? All right, you're getting a little echo, everybody, but on your mat floor, you mentioned at one point they were a 1/4 inch thick, and another point they were an 1/8 inch thick. 1/8 inches.
Okay, the mat itself, they're an 1/8 inch. That when we want to pour a leveler over the top of the mat, we need to have a 1/4 inch leveler over the top. Maybe that was
over the top of the mat, but the mat's 1/8 inch thick. Okay, yes, good.
Sir. On the mat. Now the membrane, the blue membrane with the waffles, we're looking at a 1/4. So there's your difference.
Okay, great. All right, we do have some questions. Our first question is, Barry, how do you tie into a drainage flange in a shower?
How do we tie a heated floor into a drainage flange in the shower?
Yeah, I think they're asking how you work the heating around a drainage flange.
Well, depending on what system you're using, we're not going to tie it into the flange itself. We're going to keep it several inches away from that flange. Let's go back. Let me go back a few slides here, see if I can for you. And show you that mat.
I think your question, you answered it pretty well there, but you don't really tie into the flange. You keep it around it. And,
right. You see you have this. You see the mat there with the hole.
Correct.
All right. We're not going to tie it to the flange itself. We're going to be on the outside of the flange because you're going to have all your waterproofing completed, and then we're going to have this mat over it. And see the wires much further outside of the where the flange would be.
Perfect. Perfect. All right. Our next question is, it has to do with testing the cable, I believe. It says, what kind of test do you have to do on the cable?
Well, it depends on your manufacturer. Certain manufacturers, all manufacturers I know are going to make you check the resistance of both heating cables and of the installation. Some manufacturers will require you to do more testing than that to get your warranty. That would be a megometer to do that. At Mapei itself, we require you to do 3 tests. That would be test the resistance of the heat wire before it's on the roll, during the installation, and after you cover it with the pouring. If you do all those 3 tests and do those and write it down and send it into Us as a warranty, you get a 25-year warranty. If you attend the class, which I'm an instructor in one of them, and take the class and get a Mapei Pro installer number, you get a lifetime warranty. So check with your manufacturer on what's the required tests, but those are the required tests for Mapei.
Okay, great. All right, one of our attendees, she comes to all of them, Alice Dean, asked, she said she was in a restoration discussion group today, and someone asked what the average depth of a heating element below the tile is. Her question is whether it is advisable at all to repair hollow tiles, specifically using like an epoxy injection on the heated floor. And she'd like to hear what you think of that.
Let me hear the question. So she's wanting to know, they have a hollow floor, and she's got and there's a heated wire underneath it.
So I think you can answer that part first, Barry. So definitely a hollow floor, you would want to repair that, right? You would want solid contact under there.
Right. The first thing is that you don't have enough coverage to begin with, so you really can't put a Band-Aid on that, and especially if you're just guessing of where it's hollow there and we've got a heating element under it. You'd have to remove the tile and inspect and see what you have. I wouldn't recommend just shooting a epoxy injection under any hollow floor like that.
All right. I'm being told there's no sound. I hope I'm on now. Anyhow, so how about a bridge from concrete to wood? Any special attention when you're going from the two different surfaces?
We're talking about I would probably recommend that you go with the mat, the crack isolation mat, something of that nature, to bridge that. There's still going to be some movement. Without seeing it and looking to see what you're actually talking about, I'm going to assume you're probably, maybe it was an addition or something that was a slab and you're trying to add another room to it maybe, and you've got basically that joint there. So the possibility of there being a crack failure is always going to be there. You're just going to try to mitigate it using that mat, and try to isolate that.
So you're saying use the uncoupling mat, right, opposed to using the wire and pouring a self-level over the top, correct?
Yes, that's going to give you an additional benefit of trying to avoid that.
Yeah, I agree with that. That's great. I hope that answered that, Greg. All right. How do you find an accidentally cut in the cable after tiles are installed? And I think you mentioned that, but let's do that again. Your little beeper thing.
Oh, during the install or after it's cut down the road?
After installed. After installed.
Oh, after install. Well, if it's after you install it and you're doing your final test, there shouldn't be a cut. It shouldn't before you cover it up. But let's say someone, I don't know, the electrician drills a can light from underneath the house and drills up into the wire, and you're going to get a trip on the GFI. Something's going to be wrong. What you're going to have to do is contact your manufacturer, and they'll send out a technician. They use what might be, I hope I answered your question, what we call a hot pot, and they'll they're certified to do this and run a power down the line, and basically it will show a hot spot and you spot it with an infrared camera. And that's so
as I read this, I think this is for Paige. You'll have a electric little warning beeper that while you're tiling, you will know the connection is not cut as long as that thing doesn't start beeping. Once you accidentally made a cut in there, you will find it will start beeping and you'll know to stop, and you'll have to repair that at that time.
At that time,
right. Right. But in the other situation, if the tile's already down and something happens, as you mentioned, a nail goes through it, or they drill a hole in it, it cuts it, you would have to definitely have it. Is it repaired professionally, or is there a kit for that?
You would basically contact the manufacturer, and they would get in contact with a repair technician who would have the tools and to come out there.
Great. They can track it. They can use a
hopefully they can track it. Normally they can find it without having to tear the whole floor up.
All
I've
right.
seen it times where it may be easier if it's a smaller floor just to start over. But if it's a large floor, expensive, it may be worthwhile to have them try to locate the break in the cable.
Great.
Normally you have you can kind of, once the cables are covered and they're working very rarely if ever. I personally have one that's worked 28 years and never had a glitch in it. So once they're covered, just like home wire, it's wire and it's not going to just break on its own. It's going to have somebody do something to it.
Paige, I hope we answered your question. If not, in the
if you
chat
want
screen,
to,
I did put Barry's email address there, and you can definitely email him at any time. All right. How do you isolate the heated portion of the floor from the non-heated portion? Do I need a movement joint between the warm and the cold portion of the floor? I don't think you have to. You don't have to separate them and put a joint.
One thing I may have left out.
They're only going to heat a distance, right, from the wire. So
right, it only heats the electrical floor heating really only heats about 2 inches left or right of the wire. One thing you may want to make sure, especially in the colder climes, is you want a thermal break on a slab. If you've got, say, you're in a basement in, I don't know, New York, and you want to heat that room, I'd recommend putting a thermal break underneath that, which is basically an insulated layer, and then go over the top of that. But as far as between, I only want to heat the space in front of my vanity in the morning, and the rest of the bathroom I don't want to heat. You're not going to have an issue with that.
Excellent. Hey, Paige, I saw your reply on that. Could you clarify that just a little bit more? I'm not sure. While we answer the other questions, and I'll come back to that. This one here. So what would happen to a 120 volt system if they powered it by a 240 volt system?
It'd melt.
That's what I thought. So would it melt the plastic around the wire? Is that
the
what
wire would get so hot it just basically, you've seen a short in something, basically that's it. Zip. And
right.
A fire hazard occurs very quickly.
All right. Be very careful, everyone.
If you put power to the wire while on the spool, it will cause a fire. It will heat up and short. So.
All right. So it's here's the next one. So a lot of people are concerned, Barry, with a failure by nicking the wire or something like that. And it says that the wire expands and contracts with every cycle, and if a nick in the wire, if it doesn't set off the sound unit, what happens over time? Will it cause a failure? In other words, it nicks the plastic, is how I'm understanding it, but it doesn't hit the wire.
There are two wires, and they also have basically a tin braid around that are grounded, or there's a metal around that, then the PVC covering on it. Mainly the nick. If you nick, a lot of times we call it a ground bleed, which it's not a break in the wire, but it's a nick in the ground, and you get as soon as it starts to warm up, the GFI wants to click. You've nicked it, but most of the time, if you're ohming when we say ohm it, or check the resistance during that whole time of the install and afterwards, you should be able to detect that nick. If it's just when I say just a small nick, that's not going to have a problem. But a big nick, and I don't know what they're nicking it with, but these cables are fairly tough. You would have to really, I don't know, maybe drop your trowel down from off a lot, and hit it. But
I do think, Barry, I think a lot of this comes from older systems and putting it in over the years. They are changed. The wire is much stronger, or the plastic or the casing is much stronger than it used to be, say 10 years ago. Big difference in it. So
it's all the difference in the world. It's kind of like TV. A TV, the large widescreen TV. Now you can pick it up with one hand. 10 years ago you needed 3 guys. So technologies have come a long way, but as far as you worrying about nicking the cable, as long as you don't have somebody out there with a utility knife cleaning out grout joints and of that nature, mainly common sense is into play. But if you're worried about one little nick, that's not going to cause the system to fail. A shot with a nail or something.
Barry, I'm just going to throw this out for all the attendees. Check with your manufacturer with these questions. There's a lot of manufacturers and there can be differences. So always check with the manufacturer of the product. Very, very important to check ahead of time, and then when there's a situation, make sure you check with them. That's what they're there for. They're going to answer your questions very specifically and be able to help you in almost every one of these situations. The loudmouth or the electrical unit that checks the continuity. What if there's an insulation, not installation, but an insulation or factory resistance problem, failing of that? Is that detected from the loudmouth or not?
If there's an insulation nick in the insulation, none of the insulation, it'd have to be a nick into the wire.
To the wire.
But
okay.
I wouldn't put all my eggs in one basket and rely on just that the loudmouth. I would always check, and I'm sure all your manufacturers, I know at least Mapei, is we need you to check with the meter and write down the number. And there's a percentage above or below what you read when you start, what's acceptable and what's not acceptable. So if you're getting a resistance reading that's 20% different than what you started with, then there's going to be a problem somewhere in the wire. And like Jim said, you need to check with your particular manufacturer on what you may need to do and how to handle that. But
and that meter you're talking about is an ohm meter, OHM, ohm meter. And I know before they came out with these sound devices that beep when they go off, they actually had you check as you went along and write down. You would have a card where you would write down the ohm reading at certain distances in certain areas. So that's really probably the best way. But
that is it. And the ones we have, the one I have actually has we call it a squawk box. Actually only that makes that sound and has the reading. I have it when I had the meter up on the wall with a squawk on, so then I could look to see, and I always see what it was constantly resending a resistance check on the wire itself. So like I said, each manufacturer requires different tests, so not everyone's the same. So it's the installer's responsibility as well as electrician to know what they're doing with the particular product they're putting in.
We have one more question here then, Barry. You mentioned primary heat with the 15 watts per square feet, and the question is, do you need a heat loss calculation for that, or is there a heat loss calculation? I'm not so sure I understand the question, so if you can explain it.
Well, they're talking like a HVAC guy coming and doing a heat loss. You can do one with it, but your heat loss calculation is a little bit different than it was for a forced air system. But what you got to kind of take into effect, how much of the floor have you heating? You're going to heat, 90% of your floor area, or are you going to heat a small area? So it's a little bit different calculation on that. But if you're using 15 watts throughout that whole floor and you're heating, I'd say all of the appropriate space, it's going to you're not going to have a problem with heat loss because it's a different type of heating. We're not
great. We have another question here, and I think you addressed this, but it might have been when your microphone wasn't working real good. Can you run heat up a wall in a shower, such as or a shower seat?
You can put it on a shower seat, but as Mapei's, of course, you can't run it up the wall.
Okay, but you can run a cable up to
you can run a lead. You can get the one lead. Of course, you got to run the one lead up to the shower seat. That's
correct. All right.
We're not going to heat the shower walls. If you want to link
so Scott, Yeah, so Scott, we're not heating the wall exactly. We're just running a power lead or cable, right, one separate cable up to the top of the seat and then running it on the seat.
And not through the back of the wall.
Not through the back of the wall.
Right.
All right. Here we have another one. They just keep coming in. This is great. How do you know that in a specific room it will work as a primary heat? Are there calculations or something that have to be done? I think
You can you can get the square footage of your room, and you can we know what the BTUs are. We can do the square footage and get that calculation. Primary heat. You also got to calculate on what your substrate is. That's your heat loss, and basically what your insulation, or it's a modern insulation. What's your insulator in the walls and ceiling also. So that's your heat loss calculation, but it can be done.
All right, Barry. I just want all of our attendees to know thank you. I live in Minneapolis, Minnesota. It gets very cold in the winter, and these floors are phenomenal for cold weather areas, but they're also great for any place that you want to wake up in the morning. The floors are a little cooler from air conditioning. You walk in the bathroom and now you have this nice warm floor where you're standing barefoot on. So we're seeing this type of electric mats and electric heating going in everywhere now. They're fantastic. So Barry, thank you. Great information. I want to thank all of our attendees for attending. Please look for an invite for our next webinar. Will come next week, and that will be the last one before the Thanksgiving holiday, and then everybody enjoy the holiday, and I hope to see you next week on Tuesday the 15th. That's only about 5 days away. So Barry, thank you. Everybody for attending, thank you. Have a great day and weekend. Appreciate it.
Thank you, Jim. We appreciate it.
All right, bye everyone.